in your notes and write down these 4 steps. You can paraphrase a little bit here. We're going to start today with polynomial inequalities for the first few problems, and then we're going to do a couple rational inequalities also. All right, so polynomial inequalities are going to start really similarly to how we did polynomial equations. We're going to get it equal to 0 first, move everything to one side. Then we're going to factor it using one of the ways you know how to factor, find two numbers that multiply to the left and add to the middle, or difference of squares, or grouping, something like that. You're going to factor it. And then the third step, you're going to find what all of the roots are by setting each of your factors equal to 0. In inequalities, we have an extra step. So once we find the roots, which in an equation would be our solutions, we're going to now call them breaking points. And then with our breaking points, we're going to put those on a number line, and that's going to create intervals. Each interval, then, we're going to test with a test point to see if it is a solution or not a solution. And we'll talk about what that kind of looks like. We'll do some examples. All right, so it starts out like a regular polynomial. If it equals 0, factor it, find your root, all of it. And then the roots are now breaking points. And we're going to put them on a number line and test intervals with test points. Your solutions to these will be a range of numbers. We're going to put answers in interval notation like we did before with the parentheses and brackets like we did with domain and range is what we're going to use for these. All right, so let's see what one of these looks like. Start with this one. Solve, write your answer in interval notation. X squared minus 8x plus 7 is greater than 0. All right, so to start these problems, we want everything on one side, which it is here. We want it compared to 0. We have 0 on one side. That piece is done for us. Step 2, now we're going to factor it. We've got a quadratic here. Nothing in front of my x squared, so we're just looking for two numbers that multiply to the last term and add to the middle term. So what two numbers multiply to 7 and add to -8? Okay, -1 and -7. And then imagine this was an equation then. We would just take each of those factors, set them equal to 0, and get our zeros or our roots. So if I set this first factor equal to 0, I get x equals 1. And if I set the second factor equal to 0, I get x equals 7. Okay, so if it was an equation, we'd be done. In inequalities, here's what we add to this now. We're going to make a number line. And 1 and 7 we call breaking points. They're going to break our number line up into different intervals of numbers. So because I have 2 breaking points, I have 3 intervals of numbers that we now need to test. And what we want to test is in each of these intervals, is it greater than 0 or less than 0? And depending on what my inequality is, either the greater than 0 or the less than 0 intervals will be my solution. So how we do that is we pick an x in that region. It doesn't matter what x you pick as long as it's in that region. So pick easy numbers to plug in. Like I would pick probably 0 for that one on the left. For the one in the middle, I'd probably pick 2. And for the one on the right, maybe I'd pick 10. Easy numbers to plug in and evaluate. You are plugging these numbers in to where your equation is compared to 0. So in this problem, that's the original problem. And you're evaluating. So we're looking for the y's that go with these x's. So if I plug in 0 for x, what am I going to get out? 7. If I plug 2 in for x, what am I going to get? 2 squared is 4. Then it'll be -16, so it'll be -12 plus 7. -5. And then 10. 10 squared minus 8 times 10 plus 7. What does that give you? 27. Now, because you can plug different numbers in each of these regions, the number itself that we're getting out isn't super important. It's the sign of the number that we're concerned about. Are we getting out a positive or are we getting out a negative? So in that first interval, we got out a positive number. In the middle interval, we got out a negative number. And the third interval, we got a positive. So now we're looking for, are the positives or the negatives our answer? And to figure that out, you look at the original inequality sign. In this case, my polynomial is greater than 0, which means we are looking for answers that are going to give me a positive number, greater than 0. So anything that is positive is a solution, here and here. Okay. Putting my answer now in interval notation. We use a parentheses if it's not equal to. We use a bracket if it's equal to. My inequality symbol is not equal to, so everything's going to be a parentheses in this one. So my answer is going to be negative infinity to 1, then my union, 7 to positive infinity. Okay, and that's our answer. Any questions on that? All right, let's practice another one. 4x squared plus 12x is less than negative 9. 4x squared plus 12x is less than negative 9. All right, first step, I want a 0 on one of the sides. So what can we move? Add 9. 4x squared plus 12x plus 9 less than 0. Okay, so now we want to factor that. Is there a GCF? Anything that all of the terms have in common? There's not for this one, not with all of them. So you can either use the box method because there's a number in front of the x squared, or you can guess and check with the factoring. You could even, if you get really stuck, use the quadratic formula, and that'll take a minute, but that'll take you straight to whatever the breaking point is. So those are options. This one's not too bad to factor because 4x squared and 9 are both perfect squares on the front and the back there. You're going to have a special case of factoring here. You're going to get the same parentheses twice. So what times itself can give you 4x squared? 2x, that's going to go in the front. What times itself can give you 9? 3, so that's going to go in the back. And then you look at the middle term to determine what the sign is. It's not 1 plus 1 minus, because that's what it would look like if it was difference of squares. They're both the same sign. And because my middle term is positive, they're both a plus. And then you can double check it, just kind of like mentally foil that back out. The outside and the inside terms are both going to be 6x, which will give you that 12x. So either way then, if I set that equal to 0, what am I going to get? X equals negative 3 over 2. And if you use the quadratic formula, that's the answer the quadratic formula would give you. Just one answer. It would spit it out twice, negative 3 over 2. All right, number line. Put your breaking point on there. And now we just have 2 intervals we need to test. Give me a number smaller than negative 3/2. Negative 2. Give me a number bigger than negative 3/2. 0. If I can pick 0, I'm always picking 0. That's an easy number to plug in. And you are plugging those numbers in to where the equation is compared to 0. So that first line that we wrote. All right, if I plug negative 2 in, again, we're really only concerned about, are we going to get a positive or a negative answer out? That's all we need to know. So negative 2 squared would give me 4 times 4 is 16. And then 12 times negative 2 is negative 24. So 16 and negative 24 give me negative 8 plus 9 gives me a positive 1. More importantly, I get a positive. Okay. If you plug in 0, what are you going to get out? 9. So you get a positive. Am I looking for in this problem, according to my inequality sign, positive or negative values? It's less than 0, so we are looking for negative values. So this interval is positive, and this interval is positive, so those are not part of my solution. The only other thing that could potentially be part of your solution is the breaking point, negative 3/2. Now, negative 3/2 is a root, which means it's where it equals 0. Okay, if I plug that in, I get out 0. That's where we got that answer from. If my inequality sign had the line underneath it. If it said less than or equal to, because this is where we equal 0, this would be an answer. But because it's strictly just less than, and this is where it equals, not less than, this is also not a solution. Does that make sense? That if I have an equals to symbol here, I can use that breaking point. If I don't, I can't use that breaking point. So I can't use the breaking point, and both of the intervals on either side are not negative either. So it's double negative, not negative. But anyway, what's my answer then? There's no solution to this one. There's nowhere on the number line or no value of x that I can plug in that would give me a negative answer. Okay? Let's try one more together, like this, and then we'll get to our rational ones. X to the 4th is less than or equal to 16. All right, so compare it to 0. I'm going to move the 16 over. And now we need to factor it. No greatest common factor here. This is a special case of factoring though, right? Did you guys see it? What is this? Difference of squares. If it's two terms and a minus between, but you can take the square root of nicely, you got difference of squares. So that's going to factor to conjugates. Same terms, 1 plus, 1 minus. What times itself gives you x to the 4th? X squared. What times itself gives you 16? 4, and then real quick, you could always mentally kind of FOIL that back out and make sure it makes sense. Does anything factor more now? Because I still have some powers there. Anything factor any? This one, again, because it's a minus between the terms, is again difference of squares. So we can break it into two pieces there. That x squared plus 4, because it's a plus, we can't do anything with it. So x squared minus 4 is going to factor to what? X plus 2x minus 2. All right, so that's as much as we can factor. Now set each of your factors equal to 0. If I set x squared plus 4 equal to 0, it's a quadratic, but I can solve it with square roots. Move the 4 over, negative 4, and then what's going to happen when I take the square root there? It's going to be an I, right? I've got a negative under the square root, and we're dealing with a real number line right now, real answers. So that's not going to give us any breaking points. We're not going to worry about that. Now the other ones, if I set those equal to 0, I'm going to get plus and minus 2. And those are my two breaking points we're going to put on our number line now. Negative 2, positive 2. Pick whatever numbers you want to plug in. If it were me, I might pick like negative 3, 0, and positive 3. Okay, and we are plugging them back in where the equation is compared to 0 there. Again, we're not super concerned with the number itself, just whether it's positive or negative is what we need to know. When you plug negative 3 in, negative 3 to the 4th power, is that going to be positive or negative? It's positive. It's a pretty big positive number, right? It's 81, or even if you didn't know it's exactly 81, it's big. Minus 16 is going to be positive, right? So you get 65 when you plug it in. If you plug in 0, what do you get? Negative 16, so it's negative. And then if you plug in 3, won't you get the same answer as when you plug in negative 3? Because taking it to the 4th power, it's going to be positive. Okay. So now look at your inequality sign where the 0 is. Am I looking for positives or negatives? This time it's less than, so we want negatives, which means between negative 2 and positive 2, that interval is our solution. Use your inequality sign to determine if you're going to use brackets or parentheses. Are we going to use brackets or parentheses on my 2's? It's going to be brackets this time because we can equal those breaking points. That's what that inequality sign tells me. I can have a solution where we are equal to 0. All right. Questions on that one? All right, so we have 2 more problems to go. The last 2 problems are going to be rational inequalities. The steps for these are very similar. This time, though, you're going to have a numerator and a denominator rather than just a single polynomial. So it's going to start out the same way, get everything on one side, But this time you're going to get breaking points from both the numerator and the denominator. So you're going to have to set the numerator equal to 0, factor that, denominator equal to 0, factor that, and you're going to get probably a lot more breaking points. Then we're going to do our number line with our test points. And then at the very end, when we determine our intervals, we're going to have to look for domain restrictions because we're going to have a variable in the denominator. A domain restriction, of course, would always have to have a parentheses next to it, never a bracket. So potentially it could be a little different than what you see in the inequality sign in the original problem because of domain restrictions. So a lot of this is similar, just a couple extra little things we need to think about because that denominator pops up now. Okay, got it? All right, first problem. X squared minus 2x minus 3 all over x squared minus 2x minus 8 is less than or equal to 0. All right, so starting out the same way, you want a 0 on one side. We've got that already in this problem. You also want to have a single numerator or denominator like this already is. If you have several fractions added or subtracted, you need to put those together before you can start factoring things. So again, we have a single fraction, that's good. All right, so now we're going to factor our numerator and our denominator. In the numerator, give me two numbers that multiply to -3 and add to -2. -3 and +1. Okay, in the denominator, two numbers that multiply to -8 and add to -2. -4 and 2, bring down my inequality sign, less than or equal to. Now we're going to set all of those factors equal to 0. If I set the numerator factors equal to 0, I will get x equals what? +3, -1. The denominator, if I set those equal to 0, I will get 4 and -2. 4 and -2, though, because they come from the denominator, are what? Domain restrictions. So instead of saying equal to, I'm going to say not equal to there. I've got to remember that. It's kind of like a note to self for the very end. No matter what that inequality sign says, where it's equal to, not equal to, at 4 and -2, if they appear in my answer, there must be a parentheses next to those because those are domain restrictions. All right, set up your number line. Make sure you put all your numbers in order here. -2, -1, 3, 4. And now we have a bunch of different intervals to test. We've got 5 intervals. Now you can do this by hand. You can plug in numbers. I'm going to show you how you can use your calculator if you have that available to you, just to get the pluses and minuses at least. Okay? So what I want you to do is just in y equals, type in that equation where it's compared to 0. So in here, in this problem, it would be my original equation. So alpha y equals, let's get that fraction set up, x squared minus 2x minus 3, and then the denominator x squared minus 2x minus 8. All right, so get that in there. We're also going to change one setting in your calculator. We're going to use the table of values in a minute, but your table of values right now counts by ones, and you can see that there are sometimes places like this problem where you're going to need something between 2 integers. You're going to need some decimals or fractions. So we're going to set our table up, instead of to count by ones, it's going to count by halves. To do that, hit second window, and then table start, it doesn't matter what that's at. You can just put a 0 there if you want to. And then what we really need to change there is triangle TBL. So that means change in the table. So that's what our table is going to count by. And yours is probably a 1 right now. I want you to change it to a 0.5. And it'll stay like that until you go back into the table settings and change it. So again, the table settings is just where it says table sets, if you ever want to just change that back to a 1. So now if you hit second graph, your table, you'll see that your x's count by halves. And you can find numbers that you would otherwise be plugging in by hand to get these test points. So if you scroll, for example, to all the numbers smaller than -2, all of the y values that go with those are what? Remember, all we care about is positive or negative right now. All the numbers smaller than -2, if I look on my x's, the y's are positive. That's what we need from this table. Now look between -1 and -2 on your table. So at -1.5, is my y positive or negative? You should see a negative number there. By the way, do you see that -2 and -1 say error and 0 next to them? So if it's coming from the numerator, if it's a breaking point, it'll say 0 next to it. If it's coming from the denominator, if it's a domain restriction, it'll say error next to it. So the calculator is kind of confirming that you got the right breaking points. If these are the correct breaking points at all of those values in your table, you should see either 0 or you should see error. Okay. What about between -1 and 3? Is it positive? I think this one alternates like that. I will tell you actually too, most of the time these problems will alternate sign, negative, positive, or positive, negative. It doesn't always happen. I would say about 5% of the time that doesn't happen. So you're going to see that pattern a lot, but it doesn't always work like that. So make sure you check every single interval. All right, are we looking for the positives or the negatives? Less than, so we're looking for the negatives. There are 2 intervals between -2 and -1. And then between 3 and 4. All we have to do now is put in my inequality sign, so my parentheses and my brackets from the inequality sign. All right, my original problem said less than or equal to. Equal to means bracket. We're going to use brackets, except at my domain restrictions. 4 and -2, because they are domain restrictions, are going to have parentheses next to them. The other numbers, you just follow whatever the original problem is. In this case, because there was an equal sign there, we use a bracket. And that's your answer. Okay? All right, we're just going to do one more problem to wrap this up. This one. 2 is greater than 2x over 3x minus 4. All right, step number 1, I want to get it equal to 0. I'm going to move the 2 to the other side because I don't want to move that fraction. So it's going to be 0 greater than 2x over 3x minus 4 minus 2. I'm going to move the 2 over. I'm going to make that minus 2 a 2 over 1 so I can see the fraction, because the next thing you're going to have to do is put these together. You're going to have to add or subtract the fractions, which means I need a common denominator. What's the common denominator here? 3x minus 4. So the first fraction's good. multiply the second fraction, like we did when we were solving these earlier this week, by that common denominator over itself. So now I'm going to have 0 greater than, first fraction doesn't change. Instead of a -2, remember you can think of that like plus and then distribute the negative through. So that'll be a little easier when you start putting them together. So if I distribute the -2 in, I'm going to have a -6x and a +8. And now I've got my common denominator, add them together. Denominator, 3x minus 4. Numerator, I need to do 2x and -6x, so -4x plus 8. So a little setup with this one. I got it compared to 0. I got a single fraction. That's all good. Next thing we do is factor. Does anything have to factor here? Do I have any powers? No, they're already linear terms. So you don't have to factor. You can just set the numerator and denominator is equal to 0 to get your breaking points. If you set the numerator equal to 0, and you can write this out in the margin if you need to, you would have to subtract 8 and divide by -4, bless you, so you get x equals 2. In the denominator, if you set that equal to 0, you'd have to add 4 and divide by 3, so 4/3, and then note to self, 4/3 is a domain restriction, so it came from the denominator, not equal to there. Set up your number line. 4/3, which is like 1 1/3, and 2. You have 3 intervals to test. So now in your calculator, what you see in purple there, where it's compared to 0, that's probably what I would put in my calculator in y equals. I wouldn't, worry about any of this because you could have made a mistake there. I'd look at the close to the original problem as you can get. So go ahead and put that in your y equals. We use our table again. 2x over 3x minus 4 minus 2. And then check each of these intervals in your table of values to see if they're giving you positive or negative y's. All the numbers smaller than 4/3, like 0. Is it a positive or a negative? In this first interval, are your y's positive or negative in your table? Thank you. Between 4/3 and 2, there's really only one number you're going to see. 1.5 is the only number there. So find where x is 1.5 in your table. Is the y positive or negative? Positive. And then look at all your x's that are bigger than 2. Are the y's that go with them positive or negative? Negative. Okay, be careful with this because my problem's written backwards. Look at your inequality sign. Are we looking for answers that will be greater than 0 or less than 0? Less than 0. Here, my rational function is less than 0, which means we are looking for negatives, which would be the first and the last intervals here. Then I have to figure out, am I going to use parentheses or brackets? Well, the inequality sign is strictly just greater than, less than, right? No equal signs. So that means everything is going to be a parentheses no matter what. There's nowhere that we can be equal to. So negative infinity to 4/3, union 2 to infinity, everything's a parenthesis. All right. So you guys can keep working on your math Excels. You should be able to do everything except absolute value inequality. That's what we're going to do tomorrow. I have your big idea worksheet for this section. The 2 problems on the front, there's one of each that we practiced today. These are going on the board as warm-ups tomorrow. So you can work with your group now on those 2 problems if you want. We'll start with those tomorrow, and then we'll do the backside, the absolute value. All right, let's try those 2 on the front side. And then we'll start with those warm-up problems tomorrow.